Hello, everyone, and welcome again to another edition of Encora Talks. My name is Daniela Garcia, and I will be your host in this webinar. Our topic is Declarative UI is the way, Jetpack Compose. We have such an amazing speaker. His name is Wilson Castilblanco. Wilson has over 9 years of experience in mobile development, mainly focused on Android. He has performed as a mobile developer with professional training for diagnosing and identifying needs and problems related to design, construction, evaluation, control, and maintenance of informatic systems, analysis and development of both mobile and web solutions in local, regional, national, and international organizations. Wilson is a principal software engineer at Encora and one of the winners in the last Google Jetpack Compose Challenge. Welcome, Wilson, and thank you so much for being with us today.
Thank you so much, Daniela, for having me for this warm welcome. I'm glad to hear to talk about this trending topic in the Android ecosystem, which is Jetpack Compose, which is the way. So the agenda for today will be thinking Compose. So how we can think in Compose right now. So we will be answering that question then. We will be talking about foundations, the key topics that we have to keep in mind to build composables. Then interoperability between existing code if you are thinking of migrating from existing code to Jetpack Compose. Some pros and some cons, and recommendation, finally, questions and answers. So without further ado, what is thinking in Compose? So before answering that question, we have to know what is Jetpack Compose. So that is a new toolkit created by the Android team in Google just to create a declarative UI with intuitive UI, a scalable UI, and all the beautiful thing that could be around that. So before answering the question of thinking in Compose, so we have to take a look at this function. So we have a composable, which is a function. That is what it is, a simple function. But with superpowers, that function has an annotation which is composable. So the composable is just an annotation to tell the compiler that there is a new UI element to render. So here we are reading. We are reading to some name that is coming as an argument to this function. So if we think about this UI, so this will be the outcome, hello compose. If we think about this in the imperative UI, which is the XML way, the way that we get used to use in Android to build UI, then this will be a little bit more complicated and complicating the way of having more files, for example, the XML, referencing that file to the activity, to the fragment, to the custom view, and then referencing the elements, the UI elements, for example, text. For example, the linear layout, well, that's in the linear layout already in the XML, but that's a series of steps. So that take us to this, the paradigm shift. So if we want to think in Compose, we have to do a paradigm shift because we are not longer thinking in imperative UI. We have to think about, well, from using Compose and head in the declarative UI. What is different between them? The imperative way is focused on how. So that's a series of steps to render a UI. And the declarative is just focused on what. I want to show a greeting, for example. So I just wrote that a function and a couple of text, and that's it. That will render my greeting. So that's a paradigm shift that we have to think about. So this is a little example that we have here. At the left, you can see that there is a card with some rounded corners, right? So this is the imperative UI. And to do that, we have to create a style in a different file in the imperative UI way. We have to declare the corners that we have to modify and the values, then reference that style into a card, which is the card that we are showing. And well, all the content, well, I didn't put all the content, the image, the name of the pet, and location, because that would be a little bit bigger. But it's not so bigger if we use Jetpack Compose. So, which is declarative UI. What we want to show? A card. So we declare a card. We want a rounded corner shape. We just declare a rounded corner shape class, and that's it. We have a card with rounded corners, and that will be all. So that's the shift that we to think about, because we are just writing right away what we want to show. So around the thinking in Compose, there are some problems that the Android team resolved around this. So, for example, composition over inheritance. In the view system, if we would like to build like I don't know, um, a text view behavior, a different text view behavior, or a button behavior that is different just for my needs, I could inherit from button, right? But if I would like to inherit that new button to another behavior, to a new button, then I can inherit from my button that I created, right? So that's like a levels of inheritance that could be harmful if we want to escalate. What if I have, I don't know, two buttons that shares the same behaviors of two classes? I can't inherit twice or more than once in the Android. Well, in general, I can inherit twice or more. I just have to inherit once. And what is compose? So I can have a UI element or an object in general, and I can compose it with another object. Uh, what if I want to do that in a complex way? Just compose more elements and elements if I want. So that's a pretty big difference and advantage and problem that Jetpack Compose is resolving over the view system. I can compose uh, different elements, different composables into another composables. As we saw in the first example, that little function, we have a column, we have a row, sorry, which is just a layout to arrange my internal composables into a row. So we have two text views, and that's it. So we can compose elements in that way. We can have a lot of composables you want. Uh, so also, if you would like to have like a deep hierarchy of composables, you could do that, because Jetpack Compose is will resolve that in a better way than the view system. So another principle that Jetpack Compose team resolves is the separation of concerns. That's a software principle that was applied to Jetpack Compose, and that is around two concepts: cohesion and coupling. And why cohesion and coupling? If we think about XMLs and fragments, activities, custom views, where we render this XML, we are coupling those systems. We are coupling those elements because uh, in the view system, in the imperative UI, the XML can live without the fragment activity or the uh, custom views without XMLs, and vice versa. So that's a coupling that is already there, and Jetpack Compose is there for solving that, because we are relating the same code. using Kotlin as a base code. We are not using XML anymore, just Kotlin, and that's it. We could just run um, refactorings. We could just extract our code if there is a couple itself. So we could do a lot of things. We could apply software parents into that composable if we want. The other concept is cohesion. So how my code is related is the same thing. The XML is not related in terms of code to the Kotlin code in fragments, in activity, in a custom use. They are related, but because they are UI code, but the language are not the same. The languages are not the same. So having Kotlin as the base code, as the base language, is a pretty big advantage, and in solving these important topics in software principles. Now, to talk about deeper about the foundation of Jetpack Compose, the first thing that we have to talk about is life cycle. So the life cycle of a composable, so take a look at this card. So this card is a composable, it's just a card. And it enters the composition, it recomposes 0 or more times, and leaves it in the composition. What does mean recompose? So um, every composable or every function have could have arguments, and those arguments could change over the time. So that is considered a state. We are gonna be seeing that shortly. Um, so if that state could change over the time, then the composable could change the data or its state, or the recomposition happens. So if something happens to this card, for example, the image, or I don't know, the age or something like that, if something like that changes, that will recompose the composable in this case. So this is how the lifecycle works. It's pretty simple, but we have to take into account the recomposition. That's a key concept, because if we don't care about the recomposition, we could have performance issue in our application. So now I just touched about the state, but what is a state in composable? So as I said, I have some arguments that could change over the time, and those arguments, well, the composable doesn't know about how to change if we don't tell to the compiler how to change how to recompose the composable. So we have to give the composable a hand just to change that state, to change its value if there is room of that. To do that, there is a concept which is mutable state. And the mutable state is attached to the tree of composables. That mutable state will hold the state or value that we are that could change over the time. Going back to the example about the greeting, if the name changes, so we could save that into a mutable state. But that is not enough. There is a concept which is remember. That's another composable which is store an object in memory. Why the remember exists? Because if the recomposition happens, then we have to save the state when I was before just to recover it and show the current state. If we don't have that, if we just have the mutable state plain and that's it, nothing will happen because the recomposition doesn't know about that. It knows about what is attached to the tree. That's it. Now, talking about the states. I could have stateless widgets or composables, sorry, and stateful composables. What does that mean? So the stateless doesn't hold any state. Going back to the first example, that little function is a stateful widget because it doesn't hold any state. It doesn't have a remember inside. It doesn't have any stakeholder inside. It just have an argument, and that's it. It could or it could not change. It depends if there is a stateful widget. But what is a stateful widget? Sorry, I keep telling widget, but it's composable. The composable, the stateful composables holds the states, and they are in charge of recompose and send that state to the paid stateless and to the stateless composables. In this graphic, um, there is like is represented like the paid stateful. So think about composable, which is called paid stateful, which is holding an state and is sending that state to the paid stateless. But there should be like an event going to the paid stateful to change the paid stateless. So that's how the flow of the data or the composition flow works in Jetpack Compose. So this is called unidirectional data flow, UDF. That's a concept that was applied also for architecture components and so on. But that doesn't apply only for Jetpack Compose or architecture component. That's a global term that we could use in software in general terms. Now there is another concept which is pretty important, which is state hoisting. That's a pattern which is moving the state to a caller composable, which is, for example, in this case, the paid stateful contains the state of the composable. In that case, we are just applying state hoisting. And the paid stateless will receive the state as an argument. So if we have this structure, we could have a separate composables to be able to test it, to reuse it if you want. The stateless widget will be reusable if we want, because it's just receiving a state. It's just receiving states or propagating states, and that's it. On the contrary, the paid stateful contains a state, and that is not easy to reuse. So that's why the unidirectional data flow also exists. Now, this is how the state hoisting looks like in a little example. We have a pet stateful, which is a composable. It receives a modifier, we will be talking about that shortly, and a view module. A view module acts as a stakeholder. We will be seeing that shortly too. And the state is handled by the stateful widget, in this case, pet stateful. Then the pet's UI state is sent down, to the pet stateless. And the pet stateless will take that state and propagate those changes to its children. In this case, will be pets that are the list that we want to show, for example, the list of pets. Now the stakeholders. The stakeholders manage the logic and state of composables. So in Android ecosystem, we have the view module architecture component. That's an example of view stakeholder, but that is not only the one stakeholder. I can have my own stakeholder created by myself. The view module in the architecture components is a perfect fit because it handles the configuration changes and so on. But that is not the only one. I can have my agnostic view module, and that's it. And this is how this looks like, or how the events the composition flows. So I have my composable, then the stakeholder in the last example will be like the stateful. Then I have the view module as we have here, the pet UI state. And finally, the view module could communicate to the data business layer that depends on your architecture. But how the stakeholders works. Also, we could have a class, a plain class, which is a state UI. So we could have a logic UI contained in that class just to handle all the validations around the UI, because we have states about the business logic and we have states about our UI. For example, if I'm using navigation in Jetpack Compose, uh, the navigation controller has to be in just one place. So one place should change the destination. So that could be inside a state UI, because that is not a business logic, it's just a state UI. Now, talking about side effects. Side effects is another important topic here, because the composables could have, for example, an external behavior that could affect the recomposition or the composable itself, the data, the behavior, the recomposition, etc. So we have to take into account that our composables, or that's a principle, are free of side effects. We should aim to that our composables are free of side effects. We could accomplish that. For example, you could think about, we will be showing that if there is room of time, uh, there could be, imagine that we have a list of pets and there are some categories, and we could select a category and filter that list. That's a side effect, because the list is being affected by an external behavior, which is the category, but they are not correlated. Remember that we could have a category and a list, but we can relate each other. I can have, for example, a global variable, let's say a flag or a type, pet type, as a global variable, and then being consumed by the list, because that won't work. That will cause non-behavior in my application. That's why the stakeholder should handle those states, those side effects. So we don't have global variables. You should avoid that as much as possible, because that could cause issues in the applications. Now, talking about modifiers. Modifiers is a key topic because it is how our modifiers allow to decorate or augment our composables. So, what does that mean? What if you have a card, but the card is not clickable? You could use a modifier just to add the clickable behavior to that card, or to any composable. For example, a text. A text by itself, it is not clickable, but you could change its behavior just to be clickable. You could do, for example, handle accessibility for, and that's a pretty important topic for our application, and we have to think always in accessibility, because what if a blind people, for example, is looking at our applications, or is trying to navigate our applications? There's no way, if well we have to state the accessibility just to have the right way to them to navigate through our application. Now, what about if you have to add gestures to the composables, like clickable, draggable, zoomable, swipeable? So you could do that by the modifiers, by adding modifiers to the composables. We can animate transitions, the content of our composables too. We can rotate or escalate the composables too. And finally, no, there are a bunch of cases around modifiers. This is just like the more important that I just extracted from the list, because there are a lot of behaviors that we could do, or we could decorate a composable through modifiers. There's a blur content which is only available on Android 12 and above. And this has been, in my personal experience, write a blur is always complicated, but Jetpack Compose have it has it like available in the modifiers. As I can test, this is not so powerful as we think, that we have the blur content, or we can blur content in a composable. Now, this is a little example of how the composable looks like, and the UI looks like without modifiers. We have a list of pets. We're showing an image, the name of the pet, and the age of my pet, of that pet specific. And this is how the composable looks like. We have a lazy column. We'll be talking about that shortly too. Column, that too. And say async me image will be load an image from network, from a URL, the name of the pet and the age, and that's it. But how this looks like if I apply modifiers. So this is how this looks like. So now the cards have some padding, the text too, and if you take a look closer, the image have some rounded corner too. So that will that decorate our composable, that decorate our cards. So we have field max size, which is copying the max size of the parent, the padding of my card for the piece, and if I would like to click, then just add the behavior for that. And going down to assign image, to the async image, we have a modifier occupying the max width, not the height, because if not, the card will be just fully occupied. The size of my image, and a clip. The clip is just to change how uh, the composable looks like. In this case, I would like to apply a corner shape, and that's it. And the text contains the modifier too, which is received as a parameter. This is a recommended pattern, which is receiving always the modifier in our composables. Why? Because we are not tying to the other composables to use the modifiers that we have in pets. I can add more or decorate more my pets depending on where we are showing the pets. Right? I could have this like, I don't know, I could reuse this list in another screen and add more modifiers externally. So that's why it's recommendable to send always a modifier as a parameter. That will make our composable more reusable. Now, talking about layouts, how to order our composables. So then we have a columns, we have rows, and we have boxes. The boxes acts as a stacks. So we have a composable over another. That's it. The row is just next to composable next to another, and the column one below another. But that is just to put information or order data, sorry, the composable in that way. What if I have, as the last example, um, we have a list of pets. So we have to use a lazy layouts. Why? I could just add or render, I don't know, 1,000 of pets here as a column and add a scroll behavior using a modifier. But that is not performant at all. That will affect our performance, and we have to be always in pro of the performance in our application, right? So If we use a column and we render 1000 items, that will render the 1000 items. So that will be terrible. But the lazy layouts, in the case of lazy columns, then it will only render the visible items. So if we have 1000 items, that doesn't matter. It will show only 3 items. As soon as we scroll up, scroll down, then that will render the only elements in the list that are visible. The same happens to the row. The same thing is we have a lazy row or we have a lazy grids, which is like the combination of columns and rows because we have well, we could configure the grids as we want. Okay, what you might be thinking, well, I'm working on a project and I would like to migrate my application to Jetpack Compose because Jetpack Compose is the way. Well, you could do that. You could, well, the recommendation from the Android team is just analyze your application, analyze your project. Go and write down what are the smallest components that you could begin migrating to. If not, if you start from the big component, then you will say, no, Jetpack Compose is not the way. It doesn't work at all. It just messes everything of my application. Uh, so start by little piece of code, sorry, in your project. So for example, I have let's say the card that we just see. We could instead of having that element in the XMLs, we could just declare a compose view. That's the start point of Jetpack Compose. Then in the code, we can reference this by compose view and then just use the set content. And we could put the composals, all the composals as we want. And then we could just migrate the little things, the text view, the button, the whole layout, and that's it. Then the activities. Well, this is the entry point of Jetpack Compose. So if your application or your project is using multiple activities, you could just have one as the entry point and start adding composals there. What about the fragments? If you have fragments, you could begin from there. Like instead of returning the inflated XML, you could return a compose view. And this is the set content that I was talking about, and then start adding features to the screen. So now talking about pros and cons that I have found in my experience of and also in the community. So beginning with the cons, migrating from existing projects. That could be a little bit, I don't know, complicated if your project is not following good architecture guidelines. So you could start like um, think about how to change that to start migrating to Jetpack Compose. But if that is so much complex, that could be complex. So much complex. That is not well. And I don't want to discourage you to use Jetpack Compose, but you have to think that before start using Jetpack Compose, because uh, if you start right away from the big components and the layers and so on, then that could be a headache. Now the preview is on the way of improvements. Um, Preview is a way of show our composables. As we could preview our composables individually if you want, but that is not so fast as we can. So that is in the way of improvements. And the third is not handling states in the right way. That could compromise the performance. So if you don't handle the states in the right way, or you have side effects, you could see some glitches in your application, some behaviors that are known, or inconsistencies of your data. So this is important to keep uh, or to understand better the states before you start Jetpack Compose too. I just put that as a con because that could compromise the performance, but um, at the end it's not a con because if you handle the state, that will you will build a beautiful UI, and your application will you will save a lot of lines of code too. Your application will escalate easily, and well, that will be beautiful. And what about okay? What about the recommendations that we have for that? So recommendations that we have for, well, there is a there was a pro slide that we can talk about that. The performance of our composables could be pretty much is faster than the XMLs. So that's pretty good. But that contain like a disclaimer, because the very first time you're running a Jetpack Compose, that will be a little bit slower than the XML way or the view way, because it has to render the whole 3D of the composables. So that could be a little bit slower, but that is not so slow. So the performance as a pro is beautiful. Also, the interoperability that we have, so we could just have uh, all those elements uh, to start moving on to a new project. So we could interoperate between our existing components, but and that's an advantage, because it is not you don't have to build an application from scratch. You could use the existing project. Well, the recommendations to use Jetpack Compose. So keep the composables as simple as possible. So those are functions. That's the main, I don't know, one of the main concepts or guidelines of abstraction. So if we want to refactor a code, we always begin with functions, right? So separate functions as you can, just to in favor of readability, to comprehend better the code, and to reuse the composables in a better way. Keep the composables free of side effects, as we talked before. Never declare global variables or something like that. Or always have in mind the state hoisting, just to have the composables is holding the state, and that's it. Never check the view model through the composables. And that's why, because the view module is the state holder, and the state holder is changing over time if there is an event that changes. So if you send the view model through the composables, then all the composables um, that are receiving the view module will recompose. So that will cause performance issues or unexpected behavior in your application. So always keep in mind the state hoisting pattern, uh, just to have separate widget composables with arguments, stateless, and stateful composables. Use UI stakeholders for UI logic. As I stated in the stakeholders, you could have a separate class. If you have a lot of UI logic in your new view module, you could move that to a separate class in favor of reduce the amount of attributes being sent to a composable. So you could have that as a state. Um, if a modifier is being allocated on every recomposition, make it a variable. So we saw what is a modifier. So let's think that we have a modifier changing the, not, I don't know, the size of the composable, or doing a transition inside an animation. So that animation is running every time, right? And the modifier is being allocated every recomposition. So to avoid that, you could just declare the modifier outside as a variable and reuse it. That will help you a little bit in the performance. So I don't know if there are questions that we can answer about this. I'm so sorry to go so faster, but I would like to cover these key topics. There are a bunch of other topics that we could talk about. We could just have another session to talk only about the state, because it's pretty important, or navigation, or testing. But this was like an introduction of what is Jetpack Compose, which is the way. I don't know if there is questions. If there are some questions from, um, so we are waiting if there are some questions from people. Okay, in the meantime, okay, here we go.
Hello, Wilson. Yeah, we have more questions. Thank you so much for sharing all this knowledge with us and for being part of this great initiative. So, as you just mentioned, we're ready for our Q&A. And the first question we have for you is, what are the differences between Flutter and Jetpack Compose?
Okay, very good. So first of all, they this is not a difference, but they are declarative itself, right? So we have Flutter, which is declarative too, and Jetpack Compose, but they have some difference. Like, for example, the language. So beginning with that, so Flutter is using Dart as the main language, and Jetpack Compose is using Kotlin as the main language. Also, the way of they are building the widgets or the composables, that's different. So the compiler will treat them in a different way. And I don't really know, but Flutter, I know, for example, related to React Native, is much faster than React Native, because it is not there is not like a bridge between Flutter and the widgets. Also, well, in the other hand, Jetpack Compose, um, it is building the composables directly. So I think the performance between them should be pretty similar, because we could build composables into iOS and desktop. The same for Flutter. Yeah, I think in overall that could be.
Thank you for your answer, Wilson. The next question we have for you is, what is the best architecture presentation pattern that fits to Jetpack Compose?
Well, Jetpack Compose is not about using an X or Y um, presentation pattern. So it is not tied to NVDM or NVB or NVDI. It is agnostic about that. So you could have a perfect fit, for example, in the Android ecosystem with NVDM, because NVDM is just what we are observing states of the changes that we could have, or NVI is just in favor of unidirectional data flow, so that could be also a perfect fit for Jetpack Compose. But there is not one or a choose one for Jetpack Compose. You could use whatever that do the perfect fit for your project. Or, for example, if you use um, let's say multi-platform project, a web project, um, that that is not using view module from the architecture components in Android. You have to use a different view module uh, built by yourself.
Thank you, Wilson. And I have the last question for you. What is
Okay.
the related component in Jetpack Compose for Recycler View?
Okay, we just saw that, which is lazy columns or lazy rows. So as the recycler view, we have the view holder, and it only shows or only renders the visible items. So the lazy column, the lazy row works in that way.
Mhm.
Or also the lazy grid. So having that, we could have that element. We don't have view holders anymore. We don't have diff util anymore. We just have to use lazy columns or lazy rows or lazy grids.
Thank you so much, Wilson, for your answers. And thank you, everyone, for joining us. Please keep an eye out for more webinars that we will be hosting soon. And we also invite you to watch the recorded webinars we have posted on talks.incora.com. Thank you again, Wilson.
Thank you so much, and I'm pretty glad to be here. Goodbye.